Hi, this is Brandon Baines, the Math Department at Lipscomb University. Here to talk to you today about the definition of a logarithmic function. In this presentation, you'll learn the definition of a logarithmic function, how to convert logarithmic equations to exponential form, how to convert exponential equations to logarithmic form, and also how to evaluate logarithms. The definition of a logarithm states that y is equal to the log of x with the base of a, if and only if a to the y power equals x. In this definition, a is any positive number except for 1, x is any real number greater than 0, and y is any real number. This notation is read log of x with base a. It's kind of a weird looking definition, but take a look. It says if we have a logarithm, then we can write another equation. This is an exponential equation that communicates essentially the same information, but in a different way. It also allows us to, if we have an exponential equation, to take the information communicated there and communicate it in logarithmic form. We have some special logarithms. A logarithm with a base of 10 is called the common log. It also uses special notation. That special notation is just log of x. So notice how other logarithms have a base subscript. If the base of the logarithm is 10, we do not write the subscript 10. It's understood that the base is 10. Your graphing calculator also has a log base 10 button. It's the fourth from the bottom on the far left of the calculator. The second special logarithm that we'll talk about is the natural log. The natural log uses special notation ln of x. We typically say natural log of x. It is a logarithm with a base of e. Your graphing calculator also has a natural log of x button. It's located third from the bottom on the far left. Let's take a look at converting logarithms to exponential form using the definition of logarithm. Go ahead and pause your screen and see if you can convert the following 4 logarithms into their exponential form using this definition. Using the definition of logarithm, we see that we can communicate part A as 2 to the 6th equal to 64. Part B is 10 squared equals 100. Part C as e to the 0th power equals 1. And part D, 3 to the negative 2nd power equals 1/9. Let's also practice converting exponential form to logarithmic form using the definition. So here we have 3 examples. 4 to the 3rd equals 64. 10 to the 3rd power equals 1000. 64 to the 1/2 power equals 8. Pause your screen and take a second and see if you can convert these to logarithmic form. Using the definition of logarithm, we would convert part A as a log with a base of 4 of 64 equal to 3. We'll toggle back and take a look at the exponential form. 4 to the 3rd equals 64. And here we see log of 64 with a base of 4 equals 3. Part B, we would convert to a logarithm. We would say the log of 1000 using a base 10 is equal to 3. Part C, we would say the log of 8 with a base of 64 is equal to 1/2. We're also interested in evaluating logarithms using the definition of logarithm again. Consider if you had the function f of x equals the log of x with a base of 3. You might be interested in finding the function values f of 1, f of 3, and f of 9. To find f of 1, we would do just as we've been doing with functions, let x equal 1, and we would have log of 1 with a base of 3. And we want to know what that's equal to. So we convert to exponential form, and we have the statement 3 to some unknown power is equal to 1. So we want to find out what that power would be. We could start thinking of powers of 3. 3 to the first is 3, 3 squared is 9, so on. But those aren't equal to 1. We need the power of 3 that's equal to 1. And so 3 to the 0 power must be equal to 1. Therefore, the log is equal to 0. To find f of 3, we would have the statement the log of 3 with a base of 3. We want to know what that's equal to. We could convert to exponential form, and we have 3 to some unknown power is equal to 3. Then, of course, that power should be 1. The exponent should be 1. And so f of 3 is equal to 1. To find f of 9, we have the statement the log of 9 with the base of 3. We need to know what that's equal to. Converting to exponential form, we have 3 to some unknown power is equal to 9. Thinking about exponents, we would arrive at the conclusion that it must be 2, because 3 squared is equal to 9. And so f of 9 is equal to 2. Consider the logarithmic function f of x equals the log of x plus 3 with a base of 2. Let's find f of negative 2 and f of 5. To find f of negative 2, we'd let x be negative 2. Notice that we get the log of 1 with a base of 2. And that should be 0, because 2 to the 0th is equal to 1. F of 5 is the log of 5 plus 3 with a base of 2, which is the log of 8 with a base of 2. So thinking about the exponential form, we would be thinking 2 to some power should equal 8. And thinking of powers of 2, that would be 2 to the third. And so this logarithm is equal to 3, because 2 cubed is equal to 8.